Hi, this is Phil for noabcpoker.com. In this video we're going to talk about odds, outs, and equity. This is basically one of the most fundamental things you have to learn in poker, and a lot of people tend to just skip this, even though it's really simple and you don't actually need to apply this to every hand. It's more, you need a rough understanding in the beginning and then you can move on to concepts like equity. And we're going to cover this as well today because you can actually easily convert odds and outs into equity and the other way around. So a very common scenario, I'm just going to make this my point by example. We're going to look at a common scenario like we have 10-9 diamonds, the board comes down king 6-4 on the flop with 2 diamonds. So obviously we hit a flush draw. The first thing we want to know is what odds are. This is actually very simple. Odds are essentially just a relation of the bad outcomes to the good outcomes in the pot. Okay, so what this means is that we have 52 unknown cards in the deck total. Now obviously we already know 5. We know the 5 cards in our hand and the 3 cards on the board. So now we only have 47 unknown cards. Now we want to determine how many of those help us, and obviously 9 help us. There are 13 diamonds in the deck. We have 2 diamonds in our hand and 2 diamonds on the board. So 13 minus those 4 equals 9. 9 cards help us, 38 don't. The 38 you get by just simply subtracting those 9 cards from those 47. There are 47 cards in the deck left, 9 of which help us, so 47 minus 9 do not help us, and 47 minus 9 is 38. So what that leaves us with is essentially a simple ratio. We just want to get the ratio between the cards that don't help us and the cards that do help us. So this is just the same as saying 38 to 9. So 38 times we're going to lose and 9 times we're going to win, simply because we hit our flush. You could do the same thing with a gut shot, for example. With 4 outs, this would change to, you would have 47 cards. With a gut shot, you would have 47 cards that are unknown, and we know that 4 cards help us with the gut shot. So obviously we get to 47 minus 4 to 4, which is equivalent to 43 to 4. Now the next thing we want to do is, but this is just a second example, not very important. Now what we want to do here is, this is obviously, I think for Americans it's fairly straightforward, but it's hard to compare this when you have then let's say 4 to 3 pot odds. So we want to get some normalization here. What we do to achieve this is we just simply divide both sides by the right side. So we get 38 over 9 to 9 over 9. Obviously the right side is 1, that's why we're dividing by the right side. And if you calculate this, you get to 4.2 to 1. Obviously I did this with a calculator before, I didn't do it in my head. If you would do the same thing here, you see you would roughly, if you would do the same thing here, you would get 43 divided by 4 to 4 divided by 4, so we would roughly get 11 to 1. A little bit less, 10.75 to 1. Alright. However, this was just the first step. Those are just the odds of losing for us. So what this actually tells us is that we're gonna lose 4.2 times and we're gonna win 1 time. Okay, so that means basically there's a total of 5.2 times. And of those 5.2, we're going to win 4.2. We're going to lose 4.2 and win 1. Now the second thing we have to factor in is the actual pot. Obviously now we still haven't looked at any betting action. So to factor this in, we're going to look at a scenario like this. Let's say the pot is $10. It's an easy number, and the opponent bets $6. The question is, can we call with our flush draw up here? Now basically what we're going to do is we're going to look at the pot odds. So there's a difference between odds and pot odds here. The odds, again, are a comparison of the bad cards versus good cards. Okay, and the pot odds are the pot compared to the amount to call. So again, it's just a ratio. It's simply a comparison. So what is the pot? The pot is currently $10. That was in the pot before the opponent bet, plus $6 because the opponent bet 6. Okay, and the amount to call is obviously 6, just because he bet 6, so we have to call 6. So we basically get to 16 to 6. Do the same thing as before. We divide both sides by 6. Divide by 6. Divide by 6. And you get to 2.7 to 1. What does that tell us? That tells us that out of the 3.7 times we have to win at least 1. However, we're only gonna win 1 in 5.2 because this is the total amount of times up here. So basically, what you want is this number to be bigger than this number if you break it down. This is essentially all you need to know in terms of pot odds already. It's simply a comparison of the pot size, the amount to call. Basically, it's a comparison of two ratios. The ratio of the amount to call versus the pot to the ratio of good cards versus bad cards. This is all there is to it. Now, the second question is, what about equity? This is something you hear a lot. And it seems to be a lot more complicated, but it's actually surprisingly similar to pot odds. We set up here that this is like the pot odds are just the amount to call versus the current pot. We could put current pot here. The difference to equity is that you look at the amount to call divided by the total pot after you call. So instead of just adding those two up, this is the pot and the opponent's bet, you would also put in your bet. So if we do this here, we would get to the following. We would get to, let me just get this up a little. We would get to $6. This is the amount we're going to call, divided by $10. This is the pot, plus $6. This is the opponent's bet, plus another $6. That's the one we're just calling. So we get to a total of 6 divided by 22. If you actually calculate, you get to 0.273, which is obviously the same as saying 27.3%. Alright. What it tells us is that we actually need more than 27.3% equity, or actually this is the equity needed to make a break-even call. Our actual equity has to be higher than this. This is just the equity according to the pot. In order to figure out our actual equity, we can either use something like PokerStove or Pro Poker Tools, or of course counter outs. I mean, if you have a mate hand, for example, let's say you had Ace King on this board, on the King 6-4, and you were determining whether the opponent's better or worse than you, you would just, give him a range, put it into Pro Poker Tools or PokerStove, and click calculate. If you have a draw, you can actually just do this by counting your outs. The question is, how do you determine this? Because we said, okay, we can use the outs to calculate the odds up here, but you can actually use the outs to calculate equity as well. There's a thing called the rule of 4 and 2, and it's basically a simplification because obviously every out gives you a certain amount of equity, and you can roughly get this number by simply on the flop multiplying your outs by 4 and then adding 2. If we look at what that would mean up here in the flush draw case, we have 9 outs. Let's check. We have 9 outs. Therefore, we get 9 times 4 plus 2, which is obviously equivalent to 36 plus 2, or 38. Now, we can check if this is actually true. Let me just get Pro Poker Tools up. For those of you that haven't used this yet, I can very much recommend it. So we said the board is King Diamond, 6 Diamond, 4 clubs, for example. We have 10 Diamond, 9 Diamond, and let's say the opponent has Ace King, just to give him some mate hand. If we check how much equity we have against this, we see we have 36.9%, so let's say 37. With this we got to 38, which is really accurate in fact. If we do the same thing for the turn, let's say we add a 2 of hearts here and we're on the turn, we would get, according to this, so this was the flop. If we were on the turn, we would get 9 outs still, so 9 times 2 plus 2, which is obviously 20. If we run the simulation here, we'll get to 19.7. So again, extremely accurate. You could do the same thing for something like, let's say, 8x 7y, so you have a gut shot. On the flop, that would leave us with 4 outs. We would get 4 times 4 is 16, plus 2 is 18. If if we run this, we'll see we get to 21 here. Not entirely accurate, but I mean, the last 3% are probably not that important. If we do the same thing for the turn 4 plus, sorry, what did I say? Yeah, 4 times 2 is 8, plus 2 is 10. If you simulate, we get to 9%. So again, only a difference of about 1%, which in most cases really doesn't matter all that much. So the next thing we're going to look at is the conversion of odds to equity. So what we did before was, for the odds, we looked at a ratio of a current situation compared to a potential outcome. Here in the sense of the amount to call, and further up in the sense of bad cards, good cards. Those were ratios. We already saw that for the pot equity, we looked at the amount to call divided to the total pot after recall. So basically a fraction of some absolute value. And we're actually going to do the same thing for the conversion of odds to equity. So first of all, the difference between odds and equity is that with equity, you look at all possible outcomes. Basically, the difference is that for odds, you look at the ratio, you look at the good outcomes and the bad outcomes. For equity, you look at all possible outcomes and describe the outcome as a fraction of it. Okay, so if you, instead of saying I'm going to win one time out of 5.2, or rather with odds it would be I'm going to win one time and lose 4.2. With equity, you just state how many percent of the time you're going to win. So for this, you look at all outcomes. So here this would be 47 again, of course. And now we're going to look at how often we're going to win out of those. So obviously we're going to win 9 times when our card comes. So 9 divided by 47 is the number we're looking for, which is roughly 19%. So you could say that the percentage we're looking for is roughly the favorable cases. Well, let me just copy paste this over here. You could say that the percentage we're looking for is basically the favorable cases divided by the total cases. Or in other words, the favorable cases divided by favorable plus unfavorable cases. Yeah, this is pretty much it already. If you want to convert the odds, we said before we had 4.2 to 1. If you convert this, basically all you do is you say that instead of looking at the bad outcomes on the left and the good outcomes on the right, you simply add those up. So first of all, we're going to add them up. So 4.2 plus 1 is 5.2. And now we want to look at how often we're going to win out of those 5.2. And obviously, we're going to win 1. Okay? So we're going to win 1 out of 5.2. So if we type that in a calculator, 1 divided by 5.2. Why is this not working? I know why. Divided by 5.2. We get again to 19.2%. This is pretty much all you need to convert the odds to equity. Now, the other way around is just as simple. Converting equity to odds. There's not much more to it. The general formula is equity divided by 100% minus equity. And why is that? Because again, we want to divide all our equity in the ratio. So let's say we take this example and we say we win 19%. Then obviously we're going to lose 81%. This is exactly this. You just look at the opposite basically. I mean, this is a little bit more cryptic. But obviously, instead of saying you compare the 19% to all the cases, so basically with equity you say, you compare 19 cases where you win to 100 cases total. Now what we want to do is we want to compare those 19 cases just to the bad cases. And since we win 19 out of 100, 19 out of 100 we win. Therefore, obviously, 81 out of 100 we lose. So essentially all we're doing is we're doing the same thing backwards. We're saying now, okay, 81 to 19 are our odds. Now we can do the same thing again. We can divide both sides. 81 divided by 19 to 19 divided by 19. And we'll get back to exactly 4.2 to 1. To sum it up, basically what you want to look at is when you look for odds, you want to look at the relation of good outcomes to bad outcomes And when you look at equity, you want to look at the relation of good outcomes to all outcomes. This is the essential difference. There's not much to it. I'll do one more example just to clarify. Let's say somebody states to you, you have 3-to-1 odds. That means there's a total of 4 outcomes. One outcome, one of those 4 you're going to win, and 3 of those you're going to lose. If you convert this to equity, you just look at you're going to win 1 out of those 4 times, so it's 1 divided by 4 equals 25%. Okay, let's say somebody tells you you have 35% equity, or let's say 33% equity. Therefore, 33 out of 100 times you're going to win, and obviously 67 you're going to lose. So if you want to convert this to odds and outs, you simply go 67 to 33, divide both sides by 33, 67 by 33 to 33 by 33, which is obviously the same as saying 2-to-1 roughly. I mean, 66 divided by 33 would be 2-to-1, but it's sufficiently accurate, I would say. Again, we simply converted both ways. Thanks for watching, everybody. I hope you enjoyed this. I hope it was helping in some way. If you have feedback for me, or you wish to see something, like any topic you can think of, just post in the comments and we'll make it happen. Thanks for watching. Bye.